Okay, earlier we did a finishing process on that of the side wall. Now the next thing that we would like to do is a surface finish on this sloping surface. This surface is sloping both uh, in the vertical direction, this way and that way as well. Go to the two path finishing on this surface. Okay, so maybe now this time we try the using of Flowline. Flowline is to follow the direction of the pattern of your surface. Okay, Flowline, where we would like to machine, I would like to do on this surface only. Surface and selection. So now if this is the case, the cutter will try to start from here and then it will cut across until the opposite side. However, we are having protrusion over there, which means the cutter cannot really travel across. It has to stop over here and continue elsewhere. In order not to damage this this protrusion, I need to make use of the check surface. So check surface, I say, okay, check for me this surface and that surface. So these two surfaces, cutter not supposed to touch. And selection. And next we take a look at Flowline. Now Flowline direction. If we turn on the wireframe, actually this surface we have it representation either this way or the other way. So first, understanding of this offset. And see if I work with this offset over here. These cutter lines, they are actually below the surface here on top of the surface, because the surface has two sides, so we need to tell the system which side we are cutting. And of course, in reality, the cutter won't be able to cut the bottom side, so we must select the upper side offset. Next, we take a look at the cut direction. Cut direction, we mentioned there are two principal directions. Either we cut this way or we cut that way down. So it is your own choice. Suppose I say I want to cut this way, step direction. Now step direction, you can see I can start from this side, do the cutting all the way to the other end, or vice versa. So in that case, it's up to you. And next one is a start. I can start here. I could also start from there. So your own choice. Suppose I would like to do starting from here down in this direction. Confirm. Cutter. Suppose we make use of this bull nose end mill. The parameter. So clearance 50, and then I have this V-track, I have this fit plane, and stop to leave on drive surface. Now I'm doing finishing, so this one has to be 0. Stop to leave on check surface. So this check surface, how close the cutter can come to this check surface. I can have it, for example, 0.1. That you should say it. The cutter can come as close as 0.1 away from these check surfaces. Next, pattern. This pattern will predict how good is the surface finish. We make use of the scallop height to control the surface finish, or we can make use of the step over distance. They are interrelated. Now suppose over here I'm saying I am happy with the scallop height 0.01 mm. So surface finish, roughness, scallop height, distance 0.01. Of course, when this is bigger, you get rough surface. Cutting time is shorter. Correspondingly, if you put a very small value over here, you will end up with very long cutting time. Alright, so I am agreeable to this, confirm. The system now carrying out the computation of the cutter line, and this is the cutter line according to our width starting, ending, and so on. Okay, now what we have obtained. Select all processes. I do a verify. As in before, first operation is OptiRough, which is okay with us. Okay, I get it faster. Second operation, which we also confirm over here. Now the third operation, we will clean up this surface to a scallop height of only 0.01. And there you go. Right. So this is now a much better surface finish, having scallop height of 0.1. And over here, this is the outcome. The cutter, based on that of the final product, it touches over here a little bit because we set the distance 0.1 on the check surface, and our check surface is based on the final product. Earlier, when we were doing roughing, the side wall is having 0.5 mm, so you could see that now the cutter touches a little bit over here, which is perfectly alright. We still have some allowance left in behind. And this face doesn't look good. Reason is because if you look at our actual model, now this angle, it is smaller than 90 degrees, but we are having a bull rose end mill. So the bull rose end mill will get this a flat surface rather than sloping in accordance to this. Okay, so we would like to do a file saving, and this time I like to save it as Flowline. And we shall continue in a short while.